We're now starting to broadcast live. I'm Dr. Meyer. This is the Systems Analysis and Design class, which is composed of two groups, System Brains and System Aces. This is the System Brains class. It is going to be narrated. The final presentation is going to be narrated by Nicole. And Nicole, I'm going to turn it over to you.
Lucas, take it away.
Good morning, everyone. My name is Lucas. I am part of the System Brains team. System Brains is a collective of professionals that were brought together with our intent of generating the best algorithms for the stock market. Now, our team is made up of various members, including Sashari, Nicole, Brain, Abdul, Renuka, Sanuba, Jorvi, MD, and Asia. We know how tedious it is to stay up to date with all the information on the stock market. So with that in mind, we designed these two algorithms that the team will talk about that not only stay up to date with information on the market, but help predict which stocks are best for users to invest in. We're always dedicated to having successful clients, and we strive to lead the industry developing these accurate and new algorithms using various techniques of system analysis and design. Our team used the waterfall method throughout the design of our systems, but I guess our other members can talk to you more about that.
Sure. The waterfall model. It's a structural analysis that uses the SDLC to plan and manage in system development process. The waterfall usually has 5 phases. The phase number 1 is system planning, which is the phase usually begins with a request to the IT department. The purpose of this is to create a preliminary investigation, which is feasibility study that tells the outcome development process. The phase 2 is system analysis. The process of this is to build a logical model of a new system by doing interviews, surveys, document reviews, observation, and sampling. The phase 3, system design. The purpose of this phase is to satisfy all documents required system like necessary outputs, inputs, and process to guarantee reliable, accurate, maintainable, and secure system. The phase 4 is system implementation. The purpose of this phase is to build a system by writing, then testing and document. The phase 5 is the system support and security. The purpose of this phase is to maintain, enhance, and protect the system. Can you go on the data flow? The data flow. It's also data flow, or DFD in short, hence. Also known as the level 0 DFD. It uses a functional decomposition to take a complex process, like to break it down into smaller pieces so it's easy to digest. This process is done to make it easier for developers, who is coding, or like us who are doing, Okay. This process is to make developers so they can easily digest the system, the process of the system. And also DFD maps out like the flow of any process or system, and it uses rectangles and arrows to represent each breakdown. The big rectangles, as you see over the continuation and mean reversion algorithm, uses they know as external entity to break down the process itself, and use the small rectangle, which are known as a data store. Basically, they are the lowest level of the decomposition, which are which all the data are stored over there. Last but not least, the arrows are what makes the data flow, and which is also known as data flow. The arrows, they are used to represent the data movement between different parts of the processes or the system. Each arrow has a label which determines what is coming out, in and out of the part. That's it for me.
Well, why don't I
Lucas?
talk to you guys about the decision table? We came up with 2 decision tables, one for each algorithm. They were pretty simple with only 2 conditions each. Basically deciding which stock to invest in. They're pretty straightforward, as you can see from the slide. We just check to see if the stocks had either the highest gain or the highest losses, and that would, well, for the continuation algorithm, you know, if it had the highest gains, you invest it long. If it had the I guess the lowest short, we would invest a short amount. Otherwise, we would not invest in stocks. We simply did the opposite for the mean reversion algorithm, and after we compiled our data, it became clear that the mean reversion algorithm was the preferable one of the 2.
Abdul?
Abdul is not on because we have 10 people on, so
Right.
if I could
Still
sign
have it.
off, he could sign on.
I don't think that's necessary though. I mean, one of
If you want, I can sign out and come in after he finishes.
that would be
Oh,
really helpful. Man.
I've already said my piece, so if anyone should sign off, let me do it, and I'll come
Okay.
back on.
All right.
I guess for the meantime, we could continue with the other parts until he gets in.
All right. So, our algorithms study the weekly stock of the top 10 companies by market cap and aim to inform you which one will give you the best return. We did 2 algorithms, but before called continuation and mean reversion. But before, I would like to just go through some of the how we went about collecting our data and what data we used. So essentially, we collected data from 10 companies and we gathered their opening and closing prices for a week, and we calculated based on that. We were able to use the calculate the percent gain of or loss from that specific stock using this formula: Friday close minus Monday open divided by Monday open times 100. And then this is just a little excerpt of our data. And what we did here is that, as you can see, on week 115, we used, let's say we have 9 companies that had gains and 1 that had loss. So we decided to invest 90% of our money into the highest gaining stock, and then 10% of the investors' money into the highest losing stock. And then, as you can see, sometimes we had weeks where the stocks didn't have a loss. So then we invested 100% of the money on that stock, and vice versa for the other stocks. So for the continuation algorithm, continuation patterns indicate that a price trend is likely to continue. So what we did was our algorithm invests more money on the highest gaining stock, assuming that it would gain value, and then we invest less. It invests less money on the highest losing stock. So essentially, it's buy long, sell short, and we ended up having a total bankroll amount of $83,155.91. We started out with $100,000. For the mean reversion algorithm, it's similar to our continuation algorithm, except it uses, it invests in the opposite way. So normally mean reversion trading systems evaluate markets that are unusually high or low, taking into consideration the historical average of the price or return, or the average of the growth in the economy, or the average return of an industry. But for the purpose of this project, we simplified the algorithm to just invest less money on the highest gaining stock and invest more money on the highest losing stock. So then we ended up with a total bankroll amount of $92,179.91. And we can determine that the mean reversion algorithm would be the best, will provide the investors with the best return. Since the mean reversion algorithm actually behaves like the stock market. The stock market normally tends to correct itself. So a stock that is trending up will eventually go down, whereas the continuation algorithm just, invests in the more obvious way of like the stock is going up, so we'll invest on the highest gaining stocks. But that's not how the stock market usually works or how investors invest. So Shari?
Okay. So for the questionnaire, we created a survey to have a better understanding of our audience's opinion of our algorithms. We broke down the survey into two parts: information and observations, plus questions and feedback. So with information and observations, it allowed us to get a general sense of our audience and their knowledge of stocks and algorithms. These kinds of results could easily be displayed in graphs, such as pie charts or bar charts, allowing us to correlate answers with specific numbers. So for the next part, the questions and feedback, we asked our audience more specific questions on how they feel about algorithms and their implementation on stocks. So these kinds of answers tend to be more opinion-based and can't really be displayed in a graph. Usually you have to go in a case-by-case basis to get a better understanding of what people think and their opinions. So moving forward into the next slide. Right. So moving forward with the data we gathered, where we would go into development using various methods of development. So for our group, we would decide to go with Scrum, which is a type of agile development. With Scrum, you're able to set up weekly sprints where we lay out the plans and features, as well as bugs that we're going to be working on a sprint basis. So sprint basis can be as long as a team wants, but usually they tend to be 1 week long. So these sprints would involve the developers who will write the program, the designers who create and design the layout of the program, and the product manager that deals with getting feedback from the users or the stock investors, or really any external user that deals with financing or helping out with laying down the program features. So during the week, daily stand-ups meetings will occur where we break down the progress based on 3 questions, which are: what have we accomplished so far? What will we be working on today? And is there any impediments that prevents us, like the team, from continuing the sprint? So based on these questions and feedback the product manager gives us, we're able to make smart and positive changes in our software. So I'll hand it over to Abdul to go over the Gantt chart.
Hello everyone, this is Abdul, and today I'm going to talk about the Gantt chart, which is actually a really good pictorial representation of the progress of a project, and it has been used by the system analysts for decades as well. So as we all know that we work in this project as a group, and very often it becomes difficult to keep up with the demands and the responsibilities of a project. So in order to work more effectively and show the progress of our project and to be on the same page, our team created a Gantt chart too. So firstly, we actually identified the number of tasks which needed to be completed in a given amount of time. And then we placed those tasks on the very left from top to bottom, as you can see on the Gantt chart. And on the other hand, the time interval is displayed horizontally along the y-axis. And also in order to get a better sense of how long it took us to complete our responsibilities, we also included the start and end dates, which can also be seen on the Gantt chart. As you guys can see in the chart, it took us about 74 days to collect the final data and to test and explain our algorithm. And the second most time-consuming task was to develop and test the algorithm, which actually explains how much money needs to be invested in an appropriate spot. And the remaining tasks, such as creating a mission statement, system model, and decision table, took us roughly 1 to 3 weeks to complete. And lastly, I would like to add that the Gantt chart made it easier for us to lay out our responsibilities in an organized fashion and to complete them on time. Thank you.
Okay, so this marks the end of the presentation. We kind of went over the data that it took us to the data we needed and the data we gathered to work on this project. We talked about the questionnaire and the Gantt chart. We also talked about what we'll do once we're finished, like the steps we'll take after we're done with gathering all the data, which was the Scrum and Agile development. So System Brain thanks you for your time. That is all.